Welcome back. Today I am going to talk about how to do pages 9 and 10 from the 8th grade practice and problem solving book. It starts with, and this is a review of all of 8th grade lesson 1. Look at the equations below. Tell whether each equation is true or false. So the first one, we have 3 times 5 times 3 times 7. If I use my rule, I know that this would be the same as 5 plus 7, which is 12, so that is false. Here we have 6 to the third times 3 to the third raised to the second power. So I am going to first of all use the rule where I have the same exponent, different base. I know 6 to the third times 3 to the third is 18 to the third, and then I raise that to the second power. There I multiply and I get 18 to the 6th, so that one is true. When I have 7 to the negative 6th, I know that that is the same as 7 to the 6th in the denominator, and then I have 7 to the 4th, which would give me 7 to the 10th in the denominator, so that's true because I add 6 plus 4 to get 10. Here I have 4 to the 4th times 4 to the 2nd. I have the same base, so I add the exponents. 4 plus 2 equals 6, so that is also true. This one, I have, if I use my rule for quotient, I know that it's going to be negative 4 minus 4, which is 13 to the negative 8, which is not equal to 13 to the 0. So that is false. Finally, all of this raised to the 0 power equals 1. So this is false. No matter what you have in there, if anything is raised to the 0 power, it equals 1. It says Tyler simplified the expression 5 to the 4th times 5 to the negative 9. All of his work except his answer is shown. He added 4 plus negative 9. I agree. 4 plus negative 9 is negative 5. I now know that a negative means a positive in the denominator. And so I see that right there. So I think it's B. Complete the table. All right. So if I have 10 to the 4th times 10 to the negative 2, I add 4 plus negative 2 is 2. So I am going to say that is 10 to the 2nd. Here I have the same exponent, different base, so I do 5 times 7, raise it to the 4th, which is 35, raised to the 4th power. Here, this is going to take a couple of steps. 2 to the 7th times 4 to the 7th, that is the same as 2 times 4 raised to the 7th, all raised to the 3rd. So then I have 8 to the 7th raised to the 3rd power. And then I need to go 7 times 3, and I get 8 to the 21st power. Simplify 32 to the negative 1 over 32 to the 6th. I am going to go negative 1 minus 6. I get 32 to the negative 7th power. That is going to be the same as 1 over 32 to the 7th power. They want it as a positive exponent. Write 9 to the 6th as a power with a base of 3. Well, I know that 9, 1, 2, 3, 4, 5, 6. I know 9 is the same as 3 squared, don't I? And then I just do that 6 times. But, so it's the same as 3 squared raised to the 6th power. 2 times 6 is 12. So the answer is 3 to the 12th. I'm going to circle that there. So I don't necessarily have to show every single part there, but that's just to show you why. Which expression is equivalent? Well, before I even look at these, I'm going to simplify this. I have 3 to the 4th times 5 to the 4th to the negative 3. This is the same as 15 to the 4th, because 3 times 5 is 15. I'm using my rule for same base, or same exponent, different base. I raise that to the negative 3, and that's the same as 4 times negative 3, which is negative 12, which means I have 12 in the denominator, so that would be C. Why did Tanya choose B? Well, let's see. What would she have done? It could be she did not use order of operations. She didn't use the order of operations when applying her rules.
Attention certified staff members, I will be sending this out in an email as well.